Today we will discuss last chapter of physics, chapter 7, electricity and magnetism. Short and long answer questions. State two properties of a bar magnet. Two properties of a bar magnet are: a magnet attracts small pieces of iron. A magnet always rests in the north-south direction if it is suspended so as to swing freely. 2. How will you test whether a given rod is a magnet or not? For this, we will bring one pole of a bar magnet close to both the ends of the substance, one by one. If one end is attracted and the other end is repelled, the given substance is a magnet. If both ends are attracted, the given substance is not a magnet. 3. How will you test whether a given rod is made of iron or not? To test whether a given rod is made of iron or not, we will place both the rods near a bar magnet. The iron rod gets magnetized when placed near a bar magnet due to magnetic induction. 4. You are given two similar bars, one is a magnet and the other is of soft iron. How will you distinguish and identify them? We will identify them by suspending both of them. The one which always faces in the north-south direction is the magnet and the other is the soft iron bar. 5. You are given a magnet. How will you use it to find north-south direction at a place? It is a property of magnet that it comes to rest when it is directed towards north or south pole. A freely suspended bar magnet always rests in the geographic north-south direction. Since the south pole of the Earth's magnet is closer to the geographic north, the north pole of the suspended magnet will always rest in the geographic north, and the south pole of the freely suspended magnet will point towards geographic south. 6. Describe a simple experiment to illustrate that like poles of two magnets repel each other while unlike poles attract. We will take two bar magnets A and B, suspended one magnet A with a silk thread so that it is free to swing. The magnet A will come to rest in the north-south direction. Now, holding the other magnet B in our hand and brought its north pole near the north pole of the suspended magnet, we will observe that the two poles repel each other. Now, if we bring the south pole of the magnet B near the north pole of the suspended magnet A, we will observe that the two poles attract each other. Thus, the above experiment shows that like poles repel each other while unlike poles attract each other. 7. Poles exist in pairs. Comment on this statement. If a bar magnet is broken at the middle in two parts, each part is found to be a magnet. Each part has the property to attract small iron pieces. Each part rests in the north-south direction when suspended freely. This shows that new poles are formed at the broken ends. If these pieces are broken again and again, each part will still be a complete magnet containing both the poles. Thus, the two poles of a magnet exist simultaneously. 8. What is a magnetic compass? State its use. A magnetic compass is a small magnetic needle pivoted at its center so as to rotate freely. It is used to indicate the north-south direction at a place. 9. Explain the meaning of the term magnetic field. The space around a magnet in which the magnetic needle of the magnetic compass gets influenced is called the magnetic field of that magnet. 10. What is an electromagnet? Electromagnets are temporary magnets which are made of soft iron by electrical method. 11. Name the material of an electromagnet. Electromagnets consist of coils, usually copper, wrapped tightly around a laminated core of ferromagnetic material like soft iron, steel, etc. Number 12. Draw a labeled diagram to make a soft iron bar as an electromagnet. Describe in steps the procedure. The steps to make a soft iron bar as an electromagnet are as follows. We will take a soft iron bar PQ and wind a thin insulated copper wire around the bar. Connected a cell or a battery B and a key K in series between the ends of the coil. When key K is closed, current passes through the winding of the coil and the bar becomes a magnet. As the key K is opened, the current stops flowing in the coil and the bar loses its magnetism. Thus, the bar behaves like an electromagnet when current passes through the coil. Diagram is given in page number 113, figure number 7.8. 13. You are given a U-shaped soft iron piece, insulated copper wire and a battery. Draw a circuit diagram to make a horseshoe electromagnet. The diagram is given in page 113 of your book, figure number 7.9, and this is the diagram. Number 14. Name two factors on which the strength of magnetic field of an electromagnet depends. Two factors on which the strength of magnetic field of an electromagnet depends are the number of turns of wire wound around the coil and the amount of current flowing through the wire. 15. State two ways by which the strength of magnetic field of an electromagnet can be increased. The magnetic field of the electromagnet can be increased in the following ways. By inserting a rod of soft iron or steel inside the cylindrical tube and by increasing the total number of turns of the coil. 16. State two common uses of electromagnets. Two common uses of electromagnets are for removing iron dust from wounds, for lifting and transporting big pieces of iron scrap grinders, girders, plates, etc. from one place to another. 17. Name a domestic device in which an electromagnet is used. A domestic device in which an electromagnet is used are electrical appliances like electric bell, radio, fan, etc. Number 18. Draw a neat and labeled diagram of an electric bell and describe its working. An electric bell is one of the most common applications of an electromagnet. When the switch is pushed on, the circuit gets completed and the current flows through the coil of electromagnet. This attracts the iron armature and due to the movement of armature, the hammer strikes the gong and the bell rings. But as the armature moves towards the electromagnet, the contact with the adjustment screw breaks, which breaks the closed circuit and stops the current flow. As a result, the electromagnet loses its magnetism and the armature returns to the original position. This making and breaking of the circuit of the electromagnet continues as long as the button remains pressed. Diagram is given in page 114, figure 7.11. Number 20. What is declination? Draw a diagram to show the angle between the declination and true directions of geographic north. Magnetic declination is the angle of the horizontal plane between the magnetic north and the geographic north. Figure is given in page 116 of your book, 7.12. So here students, we are finishing till question number 20. We will discuss from number 21 in our next slide. Thank you.